Any other questions? All right, I did email a worksheet as well, so good stuff. Here we come. All right, so here, wait, did I, let me see. Yeah, beautiful, good, good. Okay, so here we have this function. Now, I should be careful because normally when you have a quotient, you really do have to consider the numerator. In this class though, I'm gonna make sure the numerator is defined everywhere. Because on top, I could have something that's not defined everywhere. But for now, that's not gonna be an issue. Okay, I hope that made sense what I just said. So we have 11 over the square root of 2x minus 4, right? The numerator is a constant, so really it's defined everywhere. So now we want to know when 2x minus 4 is strictly greater than 0, right? We have a square root in a denominator. So now we want to know when 2x minus 4 is strictly greater than 0. That's what we want to know now. Okay, so we're going to solve for that. Just like before, we have to get x all alone. So how can we do that? Well, we can add 4 to both sides, right? This part's gone, and we have 2x greater than 4. 2x greater than 4. Now we divide. We want to get x all alone. We want to get this 2 out of there. How do we do that? Divide both sides by 2. So when we do that, we get x greater than 2. X greater than 2. So notice we have strict equality here, because again, since we're in the denominator, we can't have 2x minus 4 equal to 0. That's a no-no. So the domain here would be all x such that x is greater than 2, which is this interval. We have strict equality. So remember, 2 is not in the domain. So that's what we get. Okay. So that's the domain here, all x such that x is strictly greater than 2. And in fact, I actually graphed this as well here. If I were to graph this in Desmos, let me show you that. Let me show everyone that. Okay, I'm going to go to Desmos now. Share that. Remember, Desmos you can download for free on your smartphone if you want. I mean, you don't have to, but you know, wouldn't hurt. We have 11, right? Again, we're still in the graphing calculator. 11. Then here, for the square root part, you have the square root down here. Again, it starts out like this, but if you press the keyboard feature on the bottom left, the keyboard comes up. You have, what do you have? Where's that square root? Oh, right there. Square root. And then you have 2x minus 4. And that's what we get. Let me just zoom out a bit. The double arrow, the 2 arrows here hides it. You can zoom out by using the key, by plus and minus here. If you click and hold, you can move the graph. And this is what the graph will look like. Here, the vertical bar is x equals 2. Okay. But you can see 2 is not in the domain. It gets very close to 2. The graph gets very close to the vertical line. You'll study that more if you go into pre-calc, but you can see hopefully that the graph never passes through x equals 2. Okay, gets very close to it. All right, good stuff. Okay, do you have any questions about this one? Let me go back to the slides actually. Okay, here it comes. There it is. here we go. Okay, so again, this is the graph we got. This is the point 2, 0. Again, this is just showing that this vertical line is x equals 2. So, and the graph actually keeps on going. You know, it's defined for all x greater than 2. So the graph keeps on going. Any questions on this? Yeah. Yes.
So the graph keeps going right, but it never actually touches the x-axis, right?
Exactly. Very good. That's very good. The graph does. Where's the laser thing? Actually, you know what? Let me get back to Desmos. I should illustrate that. Glad someone asked about that. Awesome. I'm glad someone asked that. Let me go back to Desmos. Here we go. So you're back in Desmos, right? Again, I mean, this is something that you'll study if you go into pre-calc. But if you were to look to the right, further to the right, you can see, I mean, we're up to the 40s now, but the graph, it's never going to get to the x-axis. It never gets there. Mostly because the function 0 is not in the range. I mean, you can kind of see that from the definition of the function, right? We have 11 over the square root of 2x minus 4, right? Well, there's no way this whole thing can equal 0. There's no way y can equal 0. Because the only way that can happen is if 0 is in the numerator, and we have 11. So that's a really awesome question. So, okay. I mean, it's actually what they call an asymptote, but again, I don't really want to get into that too much. I mean, the book does, because the book's actually for a pre-calc, but that's something I'm not covering now. All right. All right, cool. Okay. All right, let's go back to the slides. Oh, wait, are there any other questions, though? All right, cool. Now we're going to see another kind of function called a polynomial function. See? Polynomial function, okay? Basically, by definition, it's really what it sounds like. A polynomial function in x, it's a function that's given by a polynomial in x, okay? So in other words, the function, if f is what we use, if the function is called f, you know, f of x, remember that's how this is read, f of x. It's not f times x, it's f of x. F is a polynomial function if it's defined this way. You know, you have a polynomial in the variable x. Remember, the n here is the degree. That's the largest exponent of x. Okay. It turns out the domain of these functions is really nice. It's all numbers. It's everywhere. The domain is all real numbers. I mean, if you think about it, that makes sense, right? Because really, what are you doing? If you were to evaluate this at a number, you're just taking that number and raising it to positive powers. So, yeah, it should be defined everywhere. The range, that's a different story. The range actually depends on different things. We will actually see how to graph this kind here when n equals 2. In that case, we have a quadratic function. In other words, when n is 2, on the right over here, we have a polynomial of degree 2. Good. So if n is 2, we get a quadratic function. We've seen n equal to 1 already. We have a linear function. You know, that's just a non-vertical line, as you can see. Quadratic function, linear function. Okay. That's a polynomial function. We also have these kinds of functions called rational functions. If you have a function of this form, one polynomial function over another, so you have a fraction of polynomial functions, that's what this is saying, we have what's called a rational function. It's just kind of like with the integers, you get rational numbers by dividing polynomials. Same thing with rational functions. Not integers though, but you divide polynomial functions. And the domain of these is all x such that the denominator is not 0. So it's just like what we saw before. To find the domain, you determine where the denominator is 0, and then the domain is everything else. Okay. So as an example,